This video will attempt to explain the volatile metal group, otherwise known as group 12 in the periodic table. The volatile metal group includes the elements zinc, cadmium, mercury, and copernicium. Because the group has zinc at the top of its group in period 4, it is also sometimes referred to as the zinc group. Zinc, cadmium, and mercury are found in the Earth's crust, but not much is known about copernicium because it can only be created in a lab by bombarding atoms and is only used in scientific research. Elements are grouped according to the number of electrons in their outer shell. The elements in group 12 all have 2 electrons in their outer shell. This results in similar chemical behaviors. Zinc, cadmium, and mercury can quite easily lose their outer 2 electrons for covalent bonding, leaving a very stable electron shell of 18. The elements in this group have the lowest melting point in the transition metal group and are silver-white in appearance. Zinc, cadmium, and mercury have weak metallic bonds and are used to form many alloys. For this reason, they are used in a large range of electrical appliances and electronics. All 3 elements are toxic, although zinc is not as dangerous as cadmium and mercury. Using the Royal Society of Chemistry, one can observe trends in this group of elements, starting with density, which is the amount of mass per unit volume. The elements differ to one another. The amount of density increases as the period increases. Therefore, zinc has the least amount of density and mercury has the most. But these elements have similar densities within their period. Atomic radius is another trend observed. Atomic radius is half the distance between 2 unbonded atoms. All 3 electrons have very similar atomic radii. Electronegativity is the final trend observed. This is how strong an element attracts electrons. Again, as the period increases, so does the increase in electronegativity, but it is not a big difference. Group 12. Elements are placed in the periodic table according to the number of electrons in their outermost shell. Zinc, cadmium, mercury, and copernicium all have 2 electrons in their outermost shell. They are classified as transition metals because they are able to use the 2 most outer shells to form bonds with other elements. But they behave a little different to all the other transition metals because have an electronic configuration with no incomplete D shell. The atomic structure affects the properties of elements in group 12 because they can easily form covalent bonds with other elements. They all have 2 electrons in their outer shell, which allows them to form compounds with an oxidation state no larger than +2. This means they lose 2 electrons and it doesn't take a whole lot of energy for them to form bonds and compounds. Their second most outer shell is a very stable energy level of 18 electrons. Have a look now at the labeled diagram of zinc. It has an atomic number of 30, which means it has 30 protons and therefore 30 electrons, and its energy shells. One can see how it has 4 energy or electron shells, placing it in the 4th period, with the outermost shell having 2 electrons, which is why it is in the 12th group. The difference between zinc and other elements in this group is the number of electron shells. Cadmium has 5 and mercury has 6 electron shells. The elements in group 12 differ to other groups in several ways. For starters, every element has a unique atomic structure, but the elements in group 12 all have partially filled subshells with 2 electrons in their outer shell. This makes them different as a collective group to other elements. They also have the lowest boiling point of any other group. A comparison between group 12 elements and group 1 elements would also show many other differences. The elements in group 12 can be found in nature, with the exception of copernicium, which is made in a lab and not much is known about it, whereas the elements in group 1, also known as alkali metals, do not occur freely in nature. These elements include lithium, sodium, potassium, rubidium, caesium, and francium. Another difference is the ability to be reactive. The elements in group 12 are not as reactive as the elements in group 1 because group 1 elements have very low ionization energies. While group 12 elements are dangerous because of their toxicity, group 1 elements are dangerous because of their reactivity. The volatile metal group, group 12, is a unique and very important group of elements. They share similar chemical behaviors and are classified in the transition metals, although they behave somewhat differently to other transition metals. 3 of the 4 elements are found in nature and due to their structure can easily form compounds useful in making alloys.